everyone and welcome to my YouTube channel. Here's a brief introduction about myself. I am a BTech graduate and these are the subjects that I teach. So if you would like to connect with me for a one-on-one or a group session, please check out the description below. So in this particular video, we'll be discussing some more questions that were asked in ICSE previous years. So let us move on to our first question of this particular video. And in this particular question, they have asked us to prove that cos A upon 1 plus sin A then plus tan A is equal to sec A. So what we will be trying to do over here is that firstly we will be converting the particular trigonometric ratio, that is tan A, in form of sine and cos. So starting off with left hand side, we will be writing cos A divided by 1 plus sine A and plus tan A. In the next step, we will be converting the tan A portion into sine and cos. So this will be 1 plus sine A and plus sine A upon cos A. Now we can take the LCM of these portion. So while taking the LCM, we will be getting the LCM as 1 plus sine A whole multiplied with cos A. So since this particular part contains 1 plus sine A, so cos A will be getting multiplied with this one. And since over here cos A is already there, 1 plus sine A will be multiplied over here. So we can write cos A multiplied with cos A will be simply cos square A, and this will be sine A multiplied with 1 plus sine A is simply sine A plus sine square A. So we can simply write sine square A plus sine A. Now we already know that sine square theta plus cos square theta is equivalent to 1. So we will be writing 1 plus sine A and whole divided by 1 plus sine A and cos A. So as we can see, both are similar, so we can just deduct these two. So in the next step, we will be getting 1 upon cos A, which is simply sec A. And this is equivalent to right hand side. So therefore, left hand side is equals to right hand side. This is how we can prove this particular question. Now moving on to our second question, and in this particular question they have told us to prove that sine theta minus 2 cos sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So first let us start with the left hand side. So firstly we will be copying the question as it is, divided by 2 cos cube theta minus cos theta. What we can do in this case is that we can take sine theta as common in the numerator. So we will be having 1 minus 2 sine square theta whole divided by, over here also I can take cos theta as common and we will be left with 2 cos square theta minus 1. We can simply see over here that this sine theta by cos theta is simply what? Tan theta. What we just need to do is that if we are able to get rid of these two, we will reach our proving portion. So what I can do is that I already know that this particular relation sine square theta plus cos square theta is equal to 1. Let us try to convert any one of them. If I am making sine square theta as the subject, I will be getting 1 minus cos square theta. So we can do sine theta and 1 minus 2, there comes a bracket, 1 minus cos square theta, bracket close, whole divided by cos theta into 2 cos square theta minus 1. Let us open the bracket in the numerator. So we will be having sine theta 1 minus 2, minus minus is plus, 2 cos square theta divided by cos theta multiplied with 2 cos square theta minus 1. Now firstly we need to solve these. So 1 minus 2 is simply minus 1. So yes, we have reached our deduction part. That is, I can write this as 2 cos square theta minus 1 divided by cos theta and 2 cos square theta minus 1. So these two get deducted from each other. So we are left with sine theta upon cos theta, which we know is equals to tan theta only, which is our right hand side. So therefore left hand side is equals to right hand side. This is how we can prove this particular question. Maybe if you are having issues as to how I am using these things, so you may check out my first particular video which I have uploaded regarding the previous year questions. Let's move on to our next question. And in this particular question, I have a set of just two particular portions in multiplication, and all I need is simply 2. So what I can do over here is that we can convert all the trigonometric ratios in terms of sine and cos. So let us start with, if we start with left hand side, I have 1 plus cot theta minus cosec theta multiplied with 1 plus tan theta and plus sec theta. So I can write this as 1 plus cot is simply cos theta by sin theta. All these things are discussed in my first video. If you are having any difficulty, please check it out. This can be written as 1 by sin theta and 1 plus sin theta divided by cos theta plus 1 upon cos theta. What I can do is I can take the overall LCM. So if I take overall LCM as sin theta, this can be written as sin theta plus cos theta minus 1, and this over here, if I take cos theta as the LCM, I can write cos theta plus sin theta plus 1. Now we are stuck over here. What to do next? So all we have to do is to visualize carefully. I can see that over here sine plus cos theta and sine plus cos theta are very much similar. The only difference is that this particular portion over here is with minus sign and this particular portion is with plus sign. What I can say that this is acting as something A and this as B. There is a plus sign, there is a minus sign. So it is similarly 1 plus B multiplied with 1 minus B, which is simply A square minus B square. So we can apply this thing over here. So I can write that sine theta plus cos theta whole square minus 1 square divided by sine theta cos theta. After that, we can open this particular portion by the formula of a plus b whole square. So in the next step, it can be written as sine square theta plus 2 sine theta cos theta plus cos square theta plus, I hope it's minus 1 whole divided by simply sine theta upon, multiplied with cos theta. As we all know that sine square theta plus cos square theta is 1, I can write 1 plus 2 sine theta cos theta minus 1 divided by sine theta cos theta. So plus 1 minus 1 gets reduced. I get 2 sine theta cos theta divided by sine theta cos theta. These two gets deducted, these two also. What I am left with is simply 2, which is my right hand side. So this is how we can simply solve this question by just using our common methods. Let us check another question, and in this particular question also we will be trying the same methodology that we have used in the previous question. So we will be starting off with the left hand side, and in the left hand side we have cosec theta minus sine theta, then sec theta minus cos theta, and tan theta plus cot theta. Change all of these in terms of sine and cos. So we can write 1 by sine theta minus sine theta. This thing as 1 by cos theta minus cos theta, and this as sine theta upon cos theta plus cos theta upon sine theta. While taking LCM, we will be getting this as 1 minus sine square theta divided by sine theta. Over here, 1 minus cos square theta divided by cos theta, and over here this will be simply sine square theta plus cos square theta divided by sine theta cos theta. So we are almost there. Now what I can do is that I can write 1 minus sine square theta as cos square theta divided by sine theta, then multiplied with, this can be written as sine square theta divided by cos theta, and this can be written as 1 by sine theta cos theta. So clearly this cos 1 times, this cos the full time, this sine 1 times, this sine the full time. All we are left is simply 1, which is equals to right hand side. Therefore LHS is equals to RHS, and this is how we can prove these long set of questions very simply by converting them into sine and cos form. Let us check another interesting question. I can only see that there is a cot present over here. My only objective will be to convert this cot into its sine and cos counterpart, and after that just simply solving the whole question in a simple manner. So let us start with the left hand side. In the left hand side we have got cos square A divided by cos A minus sine A, then plus sine A divided by 1 minus cot A. So what we can do, this thing remains as it is, we don't need to change anything over here. But in case of the other one, I will be writing cot A as cos A upon sine A. In the next step again, do the same thing over here. Let it be as it is, cos square A by cos A minus sine A plus, in the particular denominator I have to take the LCM. So this will be simply sine A minus cos A. This sine will be moving to the numerator. So in the next step we can write these as cos square A upon cos A minus sin A plus sin square A upon sin A minus cos A. The only difference we can see in the denominator is that over here the cos is positive, over here cos is negative, over here sin is positive, negative, over here sin is positive. What we can do is that we can take negative as common over there. So this will be in this manner plus sine square A. So when we take negative common, it just get reversed, that is cos A minus sine A. Now if plus and minus get multiplied with each other, it will be negative only. So I can write cos square A divided by cos A minus sine A and then a minus sign minus sine square A divided by cos A minus sine A. So when we'll be taking the LCM, it will be as it is. So cos square A minus sine square A divided by cos A minus sine A. What we can do is that we can already see that over here it is in the form of a square minus b square. We can convert this into a plus b and a minus b. So this will be cos A plus sine A multiplied with cos A minus sine A divided by cos A minus sine A. What we can do is that we can deduct this portion. We will be having simply cos A plus sine A, which is similar to sine A plus cos A. So this is equivalent to right hand side. So therefore left hand side is equals to right hand side. This is how we can prove this particular question. Now let's move on to the last question of this particular video, and this question might seem to uh, be like a bit of a tough type of question, but this particular question just contains the concept of algebra. So if you know the concept of algebra and if you know the formula over here, it is barely of only 3-4 steps. So the only formula that is needed over here is in the form of cubes. So when I see clearly over here, I can think of a formula that was a cube plus b cube, which can be written as a plus b multiplied with a square minus ab plus b square. Let us try to implement this particular formula in this question, and let's see if we get our desired result from it. So in the left hand side we have got sine cube theta plus cos cube theta whole divided by sine theta plus cos theta. So I can write this as sine theta plus cos theta as in the form of a plus b, then a square, that will be sine square theta, minus a into b, that will be simply sine theta cos theta, plus b square, that will be cos square theta, and the whole thing will get divided by sine theta plus cos theta. Now we can see over here sine theta plus cos theta gets deducted from each other, and over here this sine square theta plus cos square theta will simply turn into 1. So all I am left with is that 1 minus sine theta cos theta, which is our right hand side. So therefore left hand side is equals to right hand side, which is proved. So as stated, this was barely of 3 to 4 step question. So these were some of the questions from the previous year questions of ICSE. So if you did like this video, do share with your friends and family who are appearing for ICSE examinations, and do comment on my videos, as it will help to reach a better part of the audience. So we will be solving some more questions that were asked in trigonometry in our next video. Thank you.